Have you ever wondered why the sky is blue? A question that sparks curiosity and prompts us to look up, don't you think? Many believe it's just a simple reflection of the ocean, or maybe just nature's preferred color palette. But in reality, the sky's cerulean hue is a captivating illusion, a complex interplay of light and our atmosphere. It's not just about the color blue, it's about the shorter wavelengths and the way our human eyes perceive light. So, it's not just a blue paint splashed across the sky by nature, but a fascinating science behind it. The real reason behind the sky's blue color lies in the way sunlight interacts with Earth's atmosphere. Sunlight is a mixture of many colors, each with different wavelengths. When this light reaches our planet's atmosphere, it meets with tiny oxygen and nitrogen molecules. This meeting triggers a process known as Rayleigh scattering. Now, let's dive a little deeper into this concept. Named after the British scientist Lord Rayleigh, this phenomenon explains how light scatters when it encounters particles smaller than its wavelength. In our case, the particles are the oxygen and nitrogen molecules in the Earth's atmosphere. The magic begins when the sunlight, composed of different colors, hits these molecules. The shorter the wavelength, the more it scatters. Blue and violet light have the shortest wavelengths, and thus scatter the most. But if that's the case, why isn't our sky violet? Well, two factors come into play here. Firstly, our sun emits more blue light than violet. Secondly, our eyes are more sensitive to blue light and less sensitive to violet light. Therefore, when we look up, the scattered blue light dominates our vision, painting the sky in its soothing and calming hue. It's not that the sky itself is blue, but rather, it's the way our eyes interpret the scattered light from the sun. So it's a game of light, its wavelengths, and our perception that paints the sky blue. But what about the red, pink, and orange hues we see during sunrise and sunset, you may ask? Well, it's the same principle of Rayleigh scattering at work, but with a twist. During sunrise and sunset, the sun is at a lower point in the sky. Because of this, sunlight travels a longer path through our atmosphere. As it does, it scatters even more of those shorter blue and violet light wavelengths. But here's the fascinating part. As the sun dips lower, the scattering of blue and violet light becomes so extensive that it gets scattered out of our line of sight. This allows the longer wavelengths of light, the reds, oranges, and pinks, to become more dominant and reach our eyes. Essentially, the depth of the sun in the sky determines the path length of sunlight through the atmosphere. And this path length, in turn, determines the degree of scattering and the color of light that we see. So, the next time you marvel at the beautiful blues or the vibrant hues of the sky, remember the amazing science that's at play.